So good morning, and thank you for having me in the schedule. The reason I'm here talking to you is SBAG's own fault, because back in January 2019, SBAG issued some findings with regard to Apophis and its very close encounter with the Earth on April 13th, 2029. And SBAG encouraged the community to really look at and discover what are the science opportunities that this amazing once per 1,000-year encounter might provide, and then encouraged the community to hold workshops to explore these things. And so I'm reporting, so we have indeed done that. I'm reporting back to you on this recent workshop. So this was a workshop that we had planned to have in Nice, France in April of 2020, exactly 9 years before the encounter. Other things intervened in 2020. So we eventually got to being a 3-day virtual meeting in November. We had 60 presentations. We were blown away. We had 60 presentations, many open discussion sessions. We maxed out at our 300 registrants, and at any given time, there were between 140 and 160 people online participating. And, we thought this workshop might be 20, 30 people. And we had, more than 100 than that. And I just want to give a shout out to Debbie Mitchell and the LPI staff, who of course are supporting this meeting, who did a fantastic job in supporting us in this workshop. So that's the summary report. Let me just remind everybody of what this Apophis thing is. We get basically daily, if not weekly, asteroid stories that are really just a nuisance. The press just loves to carry these things, but Apophis is real. This is a 340-meter asteroid that's going to come within 5.8 Earth radii. That's closer than the distance to geosynchronous satellites. That's less than 1/10 of the lunar distance. And this object at 340 meters is 300 times more massive than Tunguska and 5,000 times more massive than Chelyabinsk. I mean, this is a real object coming real close. And if you do the math and try to figure out how often does an object this large come this close, it's a once per 1,000-year event. So we're not talking decadal opportunities, we're talking 1,000-year opportunities here. And so I've tried to get this message to the decadal survey that we need to pay attention, that this is an opportunity. Let's maximize the opportunity. And anytime I talk about Apophis, because these are public meetings, I have to say 3 things. Apophis will miss the Earth. Apophis will miss the Earth. Apophis will miss the Earth, because this is going to be a big deal. Worldwide media, this is going to be a big deal. And we've got to get the message out that we know this is coming. This is an opportunity, not a threat. All right, so, as I said, we get these daily, weekly asteroid stories. But let me put this in the context of not of decades, but of centuries. This plot along the bottom axis is 200 years. And you can see the size of known objects approaching the Earth over 100 years in the past and 100 years in the present. And there's the Apophis opportunity in 2029. Again, the largest object, known object to encounter over 2 centuries. And we think this is a once per 1,000-year event. Now, why this is a big deal, it goes back to Roche 1849, because we know when small bodies encounter planets, things happen to the small bodies. And so it's what is the tidal interaction of the Earth on the small body that I think is the key science question here, and it's the key science opportunity. And I think there's an incredible parallel here to comet Shoemaker-Levy 9 back in 1993, which of course had a tidal encounter with Jupiter, and then ultimately in that case impacted Jupiter. And I'll say more about that in just a moment. But I want to make clear, at 5.8 Earth radii, Apophis is beyond the Roche limit. And so it's kind of an open question of exactly what physical effects will Apophis feel, if any, at 5.8 Earth radii. And that's really the root of the question. So the science parallels to comet Shoemaker-Levy 9 are as follows. You have to think of the Apophis 2029 opportunity as an extremely rare natural experiment discovered with a short lead time. And in fact, it's a longer lead time than we had with SL9. But my point is, and the reason why I get on my horse here, and I apologize, I'm from Lexington, Massachusetts, and I live a block away from Paul Revere's route here. But the reason I'm on my horse is that there were significant science resources dedicated to observing SL9, and there was a whole range of predictions. We just simply didn't know what was going to happen, what was going to be observable, and of course the outcome. So there's this range of predictions for the outcome, and of course the outcome was astounding, both in terms of comet physics and planetary physics and impact physics. So. Anyway, I think it's the same thing. We simply don't know what's going to happen. And so it still is, and this was really the focus of the workshop is, and still an open question, what are the once per 1,000-year science opportunities presented by Apophis? And I think it's all about the encounter physics. It's all about the encounter physics. What's physically going to happen at the time of close approach? What's going to happen to Apophis? And I think this is an opportunity because as we learn, whatever we can learn about Apophis informs the science of planetary defense. I think there's fantastic planetary science here, but pragmatically, this I think is really outstanding opportunity for the science of planetary defense. So anyway, I think it's all about the encounter physics. And the key questions that we were asking at the workshop and got addressed in the workshop is, will physical changes be induced? And if there are induced physical changes on Apophis, are they measurable? And then if we can measure them, does it give us significant advances in our knowledge of hazardous asteroids? Anyway, so I'm going to talk about these three questions. And the first answer is yes, we are rather certain that the rotational state of Apophis is going to get torqued. It's in a very slow tumbling state. And we know the orbit will get dramatically changed, and we think that the rotation state will get dramatically changed. And that in itself, that rotational torque is going to introduce surface stresses. And that's work by Toshi Hiroi and Yaji Kim. And Toshi Haribuyashi and Yaji Kim. And the question is get that advanced. Let's see, I can advance the slide. Is the magnitude, so we know there'll be stresses induced. We know enough about the basic shape of Apophis to know where in its sort of neck those stresses are most likely to be maximized. But the exact magnitude of those stresses depends on the orientation of Apophis and more details about its shape. What's the cohesion of the surface? And a lot of these basic physical questions about Apophis are being answered right now because Apophis is at its last observable opportunity as we speak before 2029. And so thank you to everyone who's allocated telescope time to the 2021 campaign opportunity. And there could possibly be even gross physical changes. It really depends, again, on the internal structure. For example, if it's a contact binary, that's the state of the object that would be maximized in terms of the maximal consequences we could observe. So that's question number one, is we do think there will be physical changes. Are they going to be measurable? And there's where the answer is absolutely clear. It could be yes, it could be no, it could be maybe or perhaps. So this is really the hard part. Joe DiMartini, a grad student at Maryland, put together this nice figure and did some estimates of where an induced seismic signal, the magnitude of possible induced seismic signal, and then showed a sort of a measurability range for a variety of techniques or projected technologies. And you can see it's at or below that measurability range. So it's really still an open question about, is there something that we can measure in the Apophis encounter? And I just want to stress why the seismic problem is so important and is such an opportunity, because over 60 years in planetary science, we've only done it twice. We've measured the moon and now Mars. So there's only been 2 objects in 60 years that we have had natural seismic measurements. And this could be the 3rd. So this really is a multi-decadal opportunity. And so I'm just saying that if we could use seismic waves and map out the interior structure of a potentially hazardous asteroid, that could be incredibly valuable future information if we ever had to actually deal with a hazardous asteroid. So I think this is an incredibly important opportunity. Anyway, but then there's science. How are small body objects interiors constructed? And so, you know, if we can measure something, will it really give us the insights? I think that's the open question. And our own Tarek Daly made this wonderful figure of all the possibilities of how objects like these might be constructed. And Brent Barbee in the workshop pointed out that strength and internal structure are in fact incredibly important information that we need to address PHAs. All right, so here's the path ahead, and here I have a really specific task and request to SBAG. As you know, I like to say Apophis provides a golden opportunity, but the gold's not included. And I just remind you, previously SBAG encouraged NASA and our community to look at the science and opportunities in planetary defense. I think the workshop was the first step. It was really more of a brainstorming exercise, but I think we really need to focus this activity and come up with the best possible answers, the best knowledge that we can. And to do that, I think we need a formal science definition team study on Apophis and the opportunity and the measurability and possible outcomes that we might expect, so we can really decide what's the best course of action going forward. And so, I've written out here a wording for maybe a finding that I hope you'll discuss in terms of encouraging the Planetary Defense Coordination Office. I believe the PDCO is the right place to toss this request, to form a science definition team to advance our understanding of the opportunity here of Apophis. I think we really need to just make it more concrete. And I think a formal science definition team study is the way to go. And I even can put up here and give you a sample statement of task for that science definition team. Basically, the first 3 items are the 3 questions that I addressed previously, so I won't read through them. But I want to bring up the 4th point, which I think is really important and really necessary for an honest discussion here of this opportunity, is I think we need to assess if we made measurements, and I don't know if they're ground-based or in situ or instrumented on the surface. I'm very agnostic about what to do. But let's say we invested significant resources to measure seismic activity on Apophis in response to its Earth encounter, and we got a null result. I think the science definition team needs to look at, does a null result to a particular level of precision really inform the internal state of hazardous asteroids? And if the answer is yes, that a null result still gives us a very constrained answer, then I think that's an incredibly important answer. And if a null result is no, we're going to be just as clueless as we started out, then that would inform the level of risk we might take in terms of expenditure. So I think it's a very high risk. I don't know what the risk is yet, but in principle, it's a high risk, but potentially very high reward, very decadal type reward if we can measure the interior of one of these asteroids. So with that, I'll stop. I will email the text of these things to either Tarek or Bonnie, whoever would like to have them, so you have them in front of you for your own discussions. And with that, I'll stop and leave a little bit of time for questions and then lunch. Thank you.
Thanks so much, Rick. We do have time for maybe 1 or 2 questions. Okay, there's one here from, there are a couple of questions. Tarek, do you want to read out the questions?
Sure. The first question is from Joel Marks. To what extent, if any, is change of the orbit undetermined prior to the flyby?
I think we have a very good handle on the change of the orbit. That's maybe a question for Brent, or like Paul Chodas could answer that very well. But I think we have very good precision on the orbit because of previous radar, and so I don't think there's a lot of uncertainties there.
Melissa Bruker asks, will you be incorporating information from the current Iowan observing campaign and modeling?
Absolutely, absolutely. We're looking forward to that, and that feeds into the physical models because the exact torque in terms of rotational and dynamical tidal stress depends exactly on what's the orientation of the object at the time they encounter. And so, I think we have multiple years of rotational coverage now. We'll be able to pin down the orientation in 2029.
And Tom Statler asks, is there anything preventing the decadal from taking this up, given that the potential opportunity is in the coming decade rather than or before an SDT?
So thank you, Tom. It's a great question. So I have presented this to the decadal. I have made a very specific, there's a white paper, and I can send anyone who requests the white paper on Apophis that very specifically asks the decadal survey to prioritize, or at least, come forward and say, yes, this is a science opportunity, and, and it should have some priority, and they'll deal with it as they may. But I think in terms of defining the science and what's the observability, I think we need that sooner. If we actually were going to do something with a mission opportunity, I think we need to kind of make a science definition for any mission to accomplish sooner than later. So the time is short.
Jennifer Scully asks, how does the loss of Arecibo affect preliminary plans for the Apophis encounter?
We're all devastated. I didn't put it in this presentation, but literally off the charts in terms of signal to noise that Arecibo could deliver, the inverse fourth power problem for radar. And so it's very painful, but Goldstone will be quite capable as well. And Verke could probably give you the very detailed answer on that, but Arecibo is painful, obviously.
And Brent did put, Barbie, I should say, put in the chat some details about the orbit. And then Mike Nolan also just contributed information about Arecibo. Says the loss of Arecibo means we'll not get a good shape model in this apparition.
Okay, I didn't know if there was any other alternative to Arecibo, this apparition. That's really painful. And I want to point out that if you hear from Dante Loretta later, the OSIRIS-REx spacecraft can get itself to Apophis after the encounter. So there is actually an existing space asset that could get to Apophis, but it can't be there watching during the encounter. So anyway, but that would be something the science definition team could look at and say, what can existing assets do? I think that could be part of the study. Really looking at what can existing assets do, and do we need to do anything in situ? Can existing assets do it? And again, without Arecibo, the pain level is high.
So we're going to break for lunch, and this was a great presentation. There's a bunch of stuff here in the chat. Gerbs Bauer put in a website for the observing campaign, and a comment that the loss of Arecibo is really big, that we can't get the shape model during this apparition. So we do have to break for lunch, Rick, but I know you have time constraints as well, but thank you so much for giving this presentation. It's great. And
all right, I'll send you the verbiage, and or if anyone who wants it, just drop me an email. And and anyone who would like the Apophis white paper, I'm happy to share that. It's of course on the Decadal website, but it's probably easier just to ask for it. I'll send it right off to you.
Okay. So I think
thanks everybody. Appreciate your time.
Yeah, we'll put the presentation up. So thank you so much. We're going to break now for the East Coast lunch for 45 minutes. Okay. Thank you so much, everyone. Thank you so much, Rick, and everyone that presented. Thank you.